Good day, everyone, and to those joining us virtually. I'm thrilled to present the work of Linyi Ding, Sizi Zhou, Jinfeng Xiao, and Jiwei Han, titled Automated Construction of Theme-Specific Knowledge Graphs. This groundbreaking research addresses the need for more detailed, theme-specific knowledge graphs, introducing a novel framework, TKG-Con, that enhances the construction of these graphs. Stay tuned as we delve into how this approach outperforms existing models and the significant role of ontology in improving accuracy. Thank you. Moving on to the key highlights of our work. Our primary motivation is to construct theme-specific knowledge graphs, or KGs, from a limited number of documents. We focus on narrower themes that require in-depth exploration and include more detailed knowledge. This approach allows us to capture finer-grained entities and triples, providing a more comprehensive understanding of the theme. We also address a significant problem with existing KGs. Traditional KGs often overlook narrower themes and may not contain detailed knowledge, including finer-grained entities and triples. Our method fills this gap, enabling the creation of more detailed and theme-specific KGs. In essence, our work is a step forward in the field of knowledge graph construction, offering a more nuanced and detailed approach to capturing and representing knowledge. In this slide, we delve into the key insights of our approach. We introduce a novel framework, TKG-Con, specifically designed for constructing theme-specific knowledge graphs. This framework operates in two sequential stages. The first stage involves recognizing entities relevant to the theme. We achieve this by constructing an ontology that includes both entities and relations, which are gathered from a hierarchy of entity categories on Wikipedia. The second stage is the actual construction of the theme-specific knowledge graph. Here, we mine possible entity mentions from theme-specific documents and map them to the closest category on the entity ontology. We then retrieve candidate relations based on these entity categories. Finally, we use contextual information to determine the relation between these entity mentions. This two-stage process allows for a more precise and theme-specific knowledge graph construction. In this slide, we're going to highlight the key contributions of our work. Our main achievement is the development of a novel framework, TKG-Con. This framework is designed to construct theme-specific knowledge graphs, and it does so more effectively than existing models. But what sets TKG-Con apart? It's the use of ontology. By incorporating ontology, TKG-Con significantly improves the accuracy of the generated relations. This means that the knowledge graphs it creates are not only theme-specific, but also highly accurate. This is a major step forward in the field of knowledge graph construction. In this slide, we delve into the key highlights of our work. Our TKG-Con framework is designed to focus on narrower themes, providing a more detailed and theme-specific knowledge graph. This is a departure from existing knowledge graphs, which often focus on broader domains. To illustrate, let's consider the example of EV battery. Our framework extracts knowledge triples from the given text, such as deep cycle batteries provide continuous electricity, and deep cycle batteries be power source of electric vehicles. These fine-grained triples offer a more in-depth exploration of the theme, which can be particularly useful for specialized purposes. The process begins with the recognition of entities, followed by the construction of a theme-specific knowledge graph. This approach allows us to capture long-tail knowledge that might be discarded in previous knowledge graphs. In essence, the TKG-Con framework offers a more nuanced and detailed exploration of specific themes, making it a valuable tool for researchers and professionals alike. Begin frame. Frame title key highlights, begin itemize, item key results, begin itemize, item. Our TKG-Con model was put to the test against existing baseline models in the construction of two theme-specific knowledge graphs. The results were impressive, showing that TKG-Con outperformed the competition. Item, we also conducted an ablation study to understand the importance of ontology in our model. Without ontology, the model was found to generate incorrect relations and even pointless phrases. This clearly shows the crucial role ontology plays in our model. Item, but when we incorporated ontology, the story was different. TKG-Con was able to avoid these issues and generate more accurate relations. This demonstrates the power of our ontology-based approach in improving the quality of knowledge graph construction. End itemize, end frame. On this slide, we delve into the heart of our paper, the overall framework of TKG-Con. As you can see in the figure, the aim of our research is to construct theme-specific knowledge graphs, or KGs, from a limited number of documents related to a specific theme. This is a challenging task, but our proposed TKG-Con framework is designed to handle it effectively. It consists of two main parts: theme ontology construction and theme KG construction. In the first part, we construct an ontology that includes both entities and relations relevant to the theme. In the second part, we use the theme specific documents to mine possible entity mentions and map them to the closest category on the entity ontology. We then retrieve candidate relations based on these entity categories and incorporate contextual information to decide the relation between these entities. This process allows us to construct a detailed and theme-specific KG. Stay tuned as we delve deeper into the methodology in the coming slides. On this slide, we're diving into the heart of our research, the overall framework of TKG-Con, which you can see in the figure. Our motivation for this work is twofold. Firstly, we identified a need for more detailed and specific knowledge graphs that focus on narrower themes. This is where our theme-specific knowledge graphs come in. They allow for a more in-depth exploration of specific themes, such as EV battery or Hamas, attack on Israel. Secondly, we noticed that existing knowledge graphs often discard finer-grained entities and triples. These are seen as long-tail knowledge, but we believe they hold valuable insights. Our approach aims to capture this overlooked information, providing a richer and more comprehensive knowledge graph. Begin a frame. Frame title: our solution. TKG-Con framework. Begin a figure. Centering: include graphics. Width equals 0.8 text width. Height equals 0.45 text height. Users proud notice projects trend GPT online. Task _ execution extracted _ paper _ data. 2404.19146v1 figures. 2404.19146v1 figure 2:1.png. Captiona Tinea. The overall framework of TKG-Con. End a figure. Begin itemize. Item: our solution to this problem is the TKG-Con framework. It's a two-part process. First, we construct a theme ontology, which includes entities and relations relevant to the theme. We gather a hierarchy of entity categories from Wikipedia and generate potential relations between each pair of entity categories. The second part is the construction of the theme KG. We mine possible entity mentions from theme-specific documents and map them to the closest category on the entity ontology. Then, we retrieve candidate relations based on the entity categories. Finally, we use contextual information to decide the relation between these two entity mentions. This approach allows us to create more detailed, theme-specific knowledge graphs that focus on narrower themes and contain finer-grained entities and triples. End itemize. End a frame. Begin a frame. Frame title: a detailed framework and experiment. Begin a figure. Centering: include graphics. Width equals 0.8 text width. Height equals 0.45 text height. Users proud notice projects trend GPT online. Task _ execution extracted _ paper _ data. 2404.19146v1 figures. 2404.19146v1 figure 3:1.png. Captiona Tinea. The detailed process of TKG-Con. End a figure. Begin itemize. Item: TKG-Con's process. Begin itemize. Item: TKG-Con begins by constructing an ontology of entities and relations relevant to the theme. This is achieved by collecting a hierarchy of entity categories from Wikipedia and generating potential relations between each pair of entity categories. The next step is the actual construction of the theme-specific KG. Here, possible entity mentions are mined from the documents and mapped to the closest category in the entity ontology. Candidate relations are then retrieved based on these entity categories. The final relation between two entity mentions is decided by incorporating contextual information. End itemize. Item: experiment. Begin itemize. The authors tested TKG-Con's performance against existing models on two theme-specific KGs. The results showed that TKG-Con outperformed other methods on all metrics, demonstrating its effectiveness in constructing theme-specific KGs from scratch. End itemize. End a frame. On this slide, we delve into the heart of our study, the overall framework of TKG-Con, which is illustrated in the figure. This framework is designed to handle the task of theme-specific knowledge graph construction. It comprises two main components: theme ontology construction and theme KG construction. To give you a clearer picture, let's consider an example of EV battery theme KG construction. Here, the framework extracts knowledge triples from the given text. For instance, from the sentence, "Deep cycle batteries are used to provide continuous electricity to run electric vehicles like forklifts. The framework can extract knowledge triples such as deep cycle batteries, provide continuous electricity, and deep cycle batteries be power source of electric vehicles. This example demonstrates the potential of our framework in extracting detailed and theme-specific knowledge from limited documents, which could be a game changer in the field of information extraction. Begin a frame. Frame title at performance analysis. Begin a figure. Centering. Include graphics. Width equals 0.8 text width. Height equals 0.45 text height. Users proud notice projects trend GPT. Online task underscore execution extracted underscore paper underscore data 2404.19146 v1 figures 2404.19146 v1 table 2:1.png captiona tinea comparison of TKGcon with other baseline methods. End of figure. Begin itemize. Item TKGcon superiority. Begin itemize. Item TKGcon outperforms other methods in extracting entities with a significant improvement in recall rate and precision. Item it also shows improvements in triple extraction and theme coherence, thanks to the guidance of theme ontology. End itemize. Item limitations of other methods. Begin itemize. Item open i.e. lacks semantic understanding, leading to incomplete and erroneous entities. Item GPT-4 base models may generate ambiguous and illogical relations or entities. End itemize, end of frame. Moving on to our discussion of related works, we first look at the existing approaches to knowledge graph construction. There are two main types of knowledge graphs. The first type is general knowledge graphs, or KGs. These KGs cover a broad spectrum of topics and domains, making them versatile but not particularly specialized. On the other hand, we have domain-specific KGs. These are more focused, targeting broader domains such as biomedical sciences, sports, and finance. They offer more specific information compared to their general counterparts. However, both types have their limitations, which we will delve into as we progress in our discussion. Begin a frame. Frame title our solution. Theme-specific knowledge graphs. Begin itemize. Item focused on narrow themes. Our approach develops theme-specific knowledge graphs, theme KGs, that concentrate on narrower themes, enabling in-depth exploration for specific research or applications. Item detailed knowledge. Theme KGs capture more detailed knowledge, including finer-grained entities and triples, to retain valuable information that general KGs might overlook. Item preservation of long-tail knowledge. Our method ensures that finer-grained entities and triples, often discarded as long-tail knowledge in existing KGs, are preserved and utilized. Item example. For instance, in an EV battery theme KG, a fine-grained triple could be deep cycle batteries, be power source of forklifts, providing more specific information than a general KG. End itemize. End a frame. Begin a frame. Frame title of the TKGcon framework. Begin itemize. Item the TKGcon framework is designed to construct theme-specific knowledge graphs from limited documents. It consists of two main parts: theme ontology construction and theme KG construction. Item in theme ontology construction, we build an ontology of entities and relations relevant to the theme. This is achieved by collecting a hierarchy of entity categories from Wikipedia and generating potential candidate relations. Item in theme KG construction, we mine possible entity mentions from the theme-specific documents and map them to the closest category on the entity ontology. We then retrieve candidate relations based on these entity categories and use contextual information to decide the relation between the entities. Item this approach allows us to create more detailed and theme-specific knowledge graphs, as demonstrated in the EV battery example. End itemize, end of frame, .. On this slide, we delve into the technical details of our proposed research. The TKGcon framework. This innovative framework is designed specifically for constructing theme-specific knowledge graphs, or KGs. The TKGcon framework is composed of two main parts. The first part is the theme ontology construction. Here, we construct an ontology that includes both entities and relations relevant to a specific theme. This is achieved by collecting a hierarchy of entity categories from Wikipedia and generating potential candidate relations. The second part is the theme KG construction. In this phase, we mine possible entity mentions from theme-specific documents and map them to the closest category on the entity ontology. We then retrieve candidate relations based on these entity categories. The final step involves incorporating contextual information to determine the relation between these two entity mentions. This framework, as you can see in the figure, provides a comprehensive approach to building theme-specific KGs. It's a significant step forward in the field of knowledge graph construction. In this slide, we delve into the technical details of our proposed research, the TKG-CON framework. This framework is divided into two main parts. The first part is theme ontology construction. Here, we start with a specific theme and use it to construct an ontology, which includes both entities and relations. To form the entity ontology, we gather a hierarchy of entity categories relevant to the theme from Wikipedia. Then, we generate potential candidate relations for each pair of these entity categories by querying language models. This comprehensive approach allows us to create a robust and theme-specific ontology. Stay tuned as we explore the second part of our framework in the next slide. In this slide, we delve into the technical details of our proposed research, specifically the theme KG construction. This process begins with theme-specific documents. From these, we mine possible entity mentions and map them to the closest category in our previously constructed entity ontology. Next, we retrieve candidate relations for each pair of entity mentions. These relations are based on the entity categories that the mentions map to. Finally, we incorporate contextual information to decide the relation between two entity mentions. This step is crucial as it allows us to accurately represent the relationship between entities in our knowledge graph. This process, as shown in the figure, forms the backbone of our TKG-CON framework, enabling us to construct detailed and theme-specific knowledge graphs. In this slide, we delve into the technical details of our proposed research. As you can see in the figure, our framework, TKG-CON, is designed to construct theme-specific knowledge graphs, or KGs. Now, what sets theme-specific KGs apart from existing general and domain-specific KGs? Well, they focus on narrower themes that require in-depth exploration. For instance, instead of a broad domain like biomedical sciences, we might focus on a specific theme like EV battery technology. Moreover, theme-specific KGs contain more detailed knowledge. They include finer-grained entities and triples, which are essentially structured pieces of knowledge. This means we can capture more specific and nuanced information, which might be overlooked in broader KGs. So, in essence, our framework is about creating a more focused and detailed map of knowledge for specific themes. This can be invaluable for researchers and professionals who need in-depth information on a particular topic. On this slide, we delve into the technical details of our proposed research, specifically focusing on the TKG-CON framework, which is illustrated in the figure. This framework is designed to construct theme-specific knowledge graphs, or theme KGs, from limited documents related to a given theme. Let's take a closer look at an example of theme KG construction. We'll use the theme EV battery for this walkthrough. The framework extracts knowledge triples from the given text, which are essentially sets of three connected entities that provide a piece of information. For instance, in our example, one such triple could be, deep cycle batteries provide continuous electricity. This process allows us to construct a detailed and theme-specific knowledge graph, which can be invaluable for in-depth exploration of specific themes. This is the essence of our TKG-CON framework, a tool that enables the creation of detailed, theme-specific knowledge graphs. In this slide, we delve deeper into the technical aspects of our proposed research, specifically, the TKG-CON framework, which is illustrated in the figure. This framework is designed to construct theme-specific knowledge graphs from a limited set of documents. We've evaluated TKG-CON against existing models, and the results are promising. The framework outperforms baseline models in constructing two theme-specific knowledge graphs. We also conducted an ablation study to compare the performance of TKG-CON with and without ontology. The results show that the use of ontology significantly improves the accuracy of the generated relations. In essence, the ontology guides the model to generate more accurate and coherent relations, avoiding the generation of incorrect or pointless phrases. This is a key aspect of our research, demonstrating the importance of ontology in theme-specific knowledge graph construction. In the next slides, we will further discuss the implications of these findings. Begin a frame title a detailed analysis of results, begin mini page, T 0.5 line width, begin itemize, item figure. Comparison of TKG-Con and baselines. Item Section 2. In-depth analysis. Begin. Itemize. Item TKG-Con outperforms other models in extracting entities with a higher recall rate and precision. This is achieved through explicit phrase mining and entity filtering. Item in terms of triple extraction and theme coherence, TKG-Con also shows significant improvements over the baselines. It can extract higher quality relations and achieve competitive theme coherence. Item, despite the strengths of GPT-4-based models, they may still generate ambiguous and illogical relations or entities. TKG-Con, by breaking the construction into multiple stages, effectively improves the recall rate of document-level triples. End itemize, end a mini page hfill, begin a mini page. T 0.5 line width, begin a figure, centering, include graphics height equals 0.8 text height, a users. Proud notice projects trend GPT online, task underscore execution, extracted underscore paper underscore data. 2404.19146v1 figures, 2404.19146v1 figure 2:1.png. Caption: a comparison of TKG-Con and baselines in terms of entity extraction, triple extraction, and theme coherence. End of figure, end a mini page, end a frame. In conclusion, we've introduced TKG-Con, a novel framework designed specifically for the construction of theme-specific knowledge graphs. This is particularly useful when we have limited documents related to a given theme. Now, what sets TKG-Con apart? It's the focus. Unlike general or domain-specific KGs, TKG-Con zeroes in on narrower themes. This allows for an in-depth exploration of specific topics, which can be invaluable for specialized purposes. Moreover, TKG-Con goes beyond the surface. It includes more detailed knowledge, incorporating finer-grained entities and triples. This means that even the most minute details, often overlooked in previous KGs, are captured and represented. For example, in a theme-specific KG about EV batteries, we don't just say, EV batteries are used in electric vehicles. We go further, specifying that deep-cycle batteries provide continuous electricity for electric vehicles like forklifts. In essence, TKG-Con is about depth, detail, and specificity. It's about capturing the long-tail knowledge that makes each theme unique. Thank you. In conclusion, our TKG-Con approach operates in two main stages. The first stage involves recognizing entities, where we identify and categorize relevant entities based on the specific theme. The second stage is the construction of the theme-specific knowledge graph, where we map entity mentions to their closest categories and determine their relations. To illustrate this, let's consider the EV battery theme KG construction. Here, TKG-Con successfully extracted knowledge triples from the given text, such as deep cycle batteries provide continuous electricity, and electric vehicles include forklifts. This example demonstrates the potential of TKG-Con in handling specific themes and extracting finer-grained, theme-specific knowledge. In essence, TKG-Con is a powerful tool for constructing theme-specific knowledge graphs, capable of providing in-depth exploration for special purposes. It's a step forward in handling long-tail knowledge that might be discarded in previous knowledge graphs. Thank you. In conclusion, there are a few key takeaways that we'd like you to remember. Firstly, our proposed framework, TKG-Con, has shown to construct theme-specific knowledge graphs more effectively than existing models. This is a significant step forward in the field. Secondly, the use of ontology in TKG-Con has greatly improved the accuracy of the generated relations. This means we can trust the connections our system makes, leading to more reliable and useful knowledge graphs. Now, let's talk about enhancements in knowledge graph construction. We found that focusing on narrower themes and including more detailed knowledge can greatly enhance the construction of knowledge graphs. This approach allows us to dive deeper into specific areas of knowledge, creating more detailed and accurate graphs. Lastly, this paper provides valuable insights into the construction of theme-specific knowledge graphs. We hope that our work will serve as a foundation for future research in this area. Thank you for your attention, and we look forward to further discussions and collaborations in the field of knowledge graph construction.